Hello. I spent most of today reading about various ways of hospital equipment and room disinfection, and I stumbled on this very interesting paper. It's actually a book chapter. This one deals with an overview of automated room disinfection systems. Very nice overview that's part of Decontamination in Hospitals and Healthcare book. And if you're interested in this topic, I certainly suggest buying the whole book. So let's go over this chapter in a little bit of detail. These researchers compare a number of automated room disinfection or ARD systems which are already in operation in the hospital. Primary four types that they're using is aerosolized hydrogen peroxide vapor, UVC, and pulsed UV systems. Again, these systems are in operation in the hospitals today. Most important question, why use them? Well, there is evidence that admitting patients into rooms that were previously occupied by the patient colonized or infected with certain pathogens increased the risk for new patients. Clearly, cleaning is a necessary step. Now, we're doing cleaning today by hand. Why is that a problem? Well, it appears that reliance on human operator making mistakes that all humans do is the major problem in this situation. Furthermore, Dr. Robert Weinstein wrote that given the choice of improving technology or improving human behavior, technology is the better choice. I tend to agree with that statement in certain situations and disagree in others, but let's see what the paper details here. Interestingly, these automated room disinfection systems were being developed for many years already, with paper referenced here published in 1901, providing a step-by-step guide on disinfecting rooms with gaseous formaldehyde. So it's a form of automated disinfection that's existed for a long time. There is evidence linking level of surface contamination with the risk of transmission. I know this is a very simple sounding fact, but still a lot of research needed to go in to generate proper data and analyze it to understand what kind of surface contamination would lead to what kind of infection. Lollianol showed that all mice became infected when exposed for 1 hour to 100 spores per square centimeter, 50% at 5 spores per square centimeter, and the concentration needed to reduce or eliminate infections were fewer than 1 spore per square centimeter, so very low concentration. So clearly, dirty surfaces lead to contamination. I know it sounds obvious, but this is something that really needs to be analyzed to draw conclusions. And of course, any such data needs to be interpreted with caution, because 1 hour, 100 spores per square centimeter, where we have patients staying in rooms for days, we need to analyze relationship between the level of surface contamination and degree of transmission, as this paper points out. Very interesting fact for me, I didn't know this about C. diff, but this graph compares C. diff transmission efficiency versus log reduction by these different disinfectants, chlorclean and HPV, offer 6 log reduction and no transmission efficiency, while 70% alcohol and untreated give you just about the same result, which is a little bit scary, don't you think? But anyway, so again, limitation of conventional cleaning is the human operator. MRSA, for example, was identified in 66% of surfaces in patient rooms following the cleaning in one study, and C. diff spores persisted in the others. So proper cleaning procedures are very difficult to design and in some cases very difficult to achieve. Another study revealed that less than 50% of high-risk objects in a hospital room were cleaned at patient discharge. There are many challenges with human operators, but something for us to think about. We need to achieve very high compliance with protocols by people who are poorly paid, low motivation, overworked, in many cases have inadequate time and inadequate skills. Some of them may not speak the language that well. So this is something that definitely needs to be addressed in the hospital setting. And of course, use of incorrect formulations and incorrect disinfectants. I mean, we mess it up in our houses all the time, I'm sure. And then, of course, there is difference between different organisms. Not all organisms respond to disinfectants the same way. So this needs to be continuously monitored and evaluated. And different rooms from different patients need different cleaning practices. Proper training could be important. However, one study showed that baseline cleaning was at 52%. After education and training, compliance went to 80 to 85%, but then dropped back down to baseline when the monthly feedback ceased. So humans are humans. Humans forever shall remain humans. So let's look at what systems are there. And the ones this study looked at in detail are aerosolized hydrogen peroxide vapor, UVC, and pulsed UV systems. This study defines an ideal system would have a short cycle time, high efficiency to eliminate pathogens from surfaces, homogeneous distribution of active agent, easy to operate, fully automated, require minimum safety measures, allow instant access to the room after decontamination, have no environmental impact, and finally, the system should have published evidence of clinical impact. So this is their ideal system, and the authors themselves claim that this would be very hard to achieve. The very nice table comparing how close the 4 technologies they look at are to the ideal system, and none of the ones they evaluated have the little check mark next to every single item. And as you can see from this table, the problems are all over the place. So you might even consider combining these systems, like combining peroxide vapor with UVC to eliminate some of the crosstalk between the check and the X. And here's a nice photo of an aerosolized hydrogen peroxide system. Here's another system that I've previously looked at for hydrogen peroxide vapor. There are UV lamps, but even as this study mentioned, most manufacturers recommend multiple cycles from different locations. UV has a line of sight problem. If you can't see the lamp can't see you and can't disinfect. So bacteria and viruses and pathogens can hide from UV. And I would imagine pulsed UV has the higher power, but probably has similar problems. Now we have a huge table, many pages. This study has, let me see, the study has almost 200 references. So this is a very thoroughly researched study. And they compare different systems in different settings. You would need to download this paper and read it. There's so many details, and they're only relevant if you're evaluating purchasing one of these systems for yourself. So you need to compare what exactly you're trying to disinfect: a class 3 safety cabinet, test chamber, microbiology safety cabinet, or something else, or a glove box, or a laboratory test chamber. This is a lot of data. Now we're getting to the meat of the study, clinical impact. There is evidence that these systems improve patient outcomes. A lot of them are summarized in this table. Something that I wanted to point out: rate of infections is not that high to begin with. So you have 1 per 1,000 patient days infections with C. diff, and with use of an ARD system, with the hydrogen peroxide vapor system, infection rate dropped from 1 to 0.4. So it's a 60% reduction. It's not that huge. Another study mentions that the rates fell significantly. What is significantly? I would imagine about the same. MRSA in a 6-year, in this study of aerosolized hydrogen peroxide, MRSA dropped from 25% to about 20%. Not that big a decrease, and it's going from 9 to 5.3 per 10,000 patients. So hospitals are pretty clean already, so this is a very challenging problem for us. Some practical considerations for these systems: well, they're systems. They need maintenance, they have some costs associated with them, they need place to be stored, and some of this is addressed in this study. Interestingly, the authors decided to include a couple of pages about other systems, like gaseous ozone was used and showed 3 to 4 log reduction at roughly 25 ppm on some bacteria, 3 log on others. Higher concentration ozone at 80 ppm mixed with 3% hydrogen peroxide and high humidity achieved a higher log reduction. So this could be possible if high humidity can be maintained in the environment. And we've observed something like this in some of our studies as well. However, there is limited information on how these ozone peroxide mixtures react with hospital materials, gowns, equipment, computers, keyboards, etc. Chlorine dioxide has been considered, but it's pretty hazardous, so there's a challenge there. There are ideas about fogging, various liquid chemistries, mixture of low concentration peroxide with low concentration peracetic acid is promising, so there are many things being considered. There's a good comparison table, but as you can see, all of the systems have something green and something red. None of the systems are fully green. And of course, there is cost to consider. These are complex machines. They're quite costly. Matter of fact, this study suggests that UVC may be the most expensive ones, with pulsed UV after. Less expensive is hydrogen peroxide vapor, and the cheapest ones are aerosolized hydrogen peroxide. However, they all have cost. They all have consumables. They all have replacement parts. They all have storage spaces. They all have training. So there are costs associated with running these. And some of these, like aerosolized hydrogen peroxide, is a fogging type system, and CDC guidelines recommend against disinfectant fogging. However, that is beginning to change. So there is light at the end of that tunnel. Hopefully there is an end to that tunnel. Another thing to consider is when you have multi-occupancy bays and you want to disinfect 1 or 2 of them. You have to move patients around if you're doing this. However, keep in mind that this can be justified in serious outbreaks like the one that's happening right now with COVID-19. And don't forget, there's of course need for pre-cleaning. So even though the automated systems can do a pretty good job at spreading disinfectant all over the room needs to be pre-cleaned to remove any kind of blood spills, anything like that. So rooms do need to be pre-cleaned still. And of course, there are validation challenges. When you have, a couple of infections per 10,000 patients, statistics for your validation become very challenging. So there are challenges with mathematical modeling, computational fluid dynamic modeling, distribution of these disinfectants in the room, time requirement, material compatibility. There are many, many challenges. And of course, there is regulation. These systems are pretty new, so regulations are still being established. What's in the future, ask us, the authors. Well, we don't know. There is no well-established relationship between level of residual contamination and how many patients get infected. So that's a challenge. We don't know if these systems will replace human workers completely. More comparison is needed. But in a closed environment, in a well-controlled environments, which hospitals are becoming and should be becoming, there is evidence, existing strong evidence that ARD systems are effective adjunct to conventional methods of terminal disinfection. Peroxide, UVC, perhaps other things that are being currently invented, additives to surfaces, different types of surface treatment, surface modification, coatings, all of that is coming. And automation is very important, including artificially intelligent systems that may be one day able to spot areas of infection. So there's a lot for us to work, and this manuscript opened my eyes to many challenges I did not think about before. So I'm very happy that I was able to find it and read it. I hope you guys would be interested enough in it to go and buy the book. Good luck.